There it is, right. Okay. So we're going to, a very brief introduction to who we are as Visure, Visure Solutions, and talking about our absolute focus on the subject of requirements management. So then I'm going to go into talk about, well, what is requirements traceability? What do we actually mean by requirements traceability? And what does it mean to, to organizations and you in relation to your daily jobs? Then I'm going to talk about some of the benefits of traceability. So with, some of the highlights there are, monitoring completeness, managing the impact of change, test management, the concept of information reuse. I mean, it's a subject which is often talked about as a good thing to do, but people obviously find it very difficult to actually achieve. And the other final part about traceability is how you can use traceability during your bid and tender management and ensuring that, whatever project or product you develop, it's always got traceability back to the original source of the why you're developing it in the first place. Then we'll go into a very brief demonstration on how we can actually show you how we can actually support traceability between requirements, and I'll talk about that a little bit more in a minute. And then finally, we'll talk about some of the business benefits or the business benefit of implementing requirements traceability, and that at the end we'll then talk about questions. So let's talk briefly about who Visure are. Visure company very much specializing in requirements engineering for system engineering and for complex IT systems. The company was founded in 2007 with the focus on delivery of innovative requirement solutions. And we are the manufacturer and distributor for Visure Requirements, which is one of the leading requirement management tool sets. We have a headquarters in Madrid in Spain, and we also have another headquarters now in San Francisco in California, USA, and here in the UK and Sweden and Germany. Because of our extensive activities in Germany, we are ISO SPICE certified, and that's predominantly associated with certification for the automotive industry. And we also promote and support an initiative from IREB, which is the International Requirements Engineering Board, for certification of requirement engineers, and we've actually got training courses that support that certification. So with that, let's move on. So what is requirements traceability? Well, I thought for this I would actually look at some diary definitions for what requirements traceability is. So requirements traceability is defined as a subdiscipline of requirements management, typically within the software development and system engineering areas. Although I have to say we're getting a lot more activity now within the more general bounds of project management. And it's so requirements traceability is concerned with the documenting the life of a requirement and providing bidirectional traceability between various associated requirements. And by the way, very often that happens across many documents. So it enables users to find the origin of each requirement and track every change that has been made to each requirement. So for this purpose, it may be necessary to document every change that is made to every requirement as part of that activity. So requirements traceability is concerned with documenting the relationship between requirements and other development artifacts. So it's proposed to facilitate the overall quality of the products under development, understanding of product under development and its artifacts, and the ability to manage change through that process. And I'll talk a little bit more about that during the presentation. So not only the requirements themselves should be traced, but also the requirements relationships with all the artifacts associated with it. And this can be things like models, pictures, analysis, results, test cases, test procedures, test results, and really documentation of all kinds. And the other one that we'll be talking about there is also compliance with standards and regulatory compliance with other areas there. So requirements traceability refers to the ability to describe and follow the life of that requirement. And and from the origins through the development and specification. So the principal relationship we refer to here is characterized by as a satisfaction of how a requirement is satisfied by those artifacts. So other relationships can be traced, for example, verification. Again, we'll talk about in a minute, and how a requirement is verified by test artifacts. So it is about trying to link up all this information. And the picture on the screen there shows you well, it's the start of a project activity, and we try and think about all the elements of the project that we're going to need to consider as part of the project. But notice the little tiny lines between each of the little pieces on that slide, and those lines effectively represent that traceability. Oops, the wrong way. So information traceability, and I define this, it's my slide of what I term chaos to order. So very often when project starts, you end up with what I term islands of information. These are autonomous bits of information, and they come in various forms. You can see here you've got Word documents, you've got notepads, you've got minutes of meetings, and Excel spreadsheets very often, and nowadays even with social media you've got things like Twitter coming into play. And on the right-hand side, you've got analysis of project progress, etc. But all of these in this form are islands of information, but they are connected. For instance, you have a meeting, and after that meeting, a decision is made, and that decision can impact on some part of the project. Well, this, to my mind, is, if you like, at the chaos end of the spectrum. These are islands of information with no actual direct connectivity between them, and the reliance of making some of that connectivity is what I term the canteen discussion, or that discussion that happens over lunch between two people working on a project, when one says, oh, you know, I've made this change, and the other one says, oh, I didn't know about that change, and that impacts on what I do. So we need to somehow move this so-called chaos into some sort of order. And so what we do is we start to take this information and we take it down into these blocks. We still capture the information very often in the same sort of way, but we're now trying to establish links between this information. And what is important about these links is the traceability is maintained not at document level, but at statement level within the documents. And it's this type of traceability that starts to bring some order and start to think about allowing us the luxury of saying, well, if one requirement changes, what is going to be the impact of other requirements across the life cycle of the project. So linking information at statement level, and that's really important, that you can't rely on just linking information at whole document level. You've got to go abstract it down to individual sentences and statements within the documents. So this is a good example. We have one system requirement, and I've identified it by those two red lines, and we need to make a change to that system requirement. Well, let's look at the potential impact of that change. So we think about here is what is the impact on system test? That's an immediate traceability that you need to think about, is what impact is it making on that associated system test that may be associated with that system requirement you're talking about. The next question we need to ask is, are we still compliant with what we originally set out to achieve, or what the customer requirement originally stated? And now I'll come back on that one to some of the tendering process that very often occasionally we get involved with. So are we still compliant with what the customer originally asked for if we were to make this change? And of course, if it has an impact on the customer requirement, we need to ask the question, will the same verification criteria still apply to that customer requirement? So this is all, don't forget, being derived from just one change to one requirement statement in one document. Now we start to look down the tree. What is the impact on the subsystem requirement? So now you start to go down the tree where that system specification starts to define and derive. From that we derive subsystem specifications and subsystem requirements. And of course, if that changes, in what way will it affect the subsystem tests? So very quickly, through this one change to one requirement statement in one document, you can see how it actually spreads out, motivating potentially changes to other documents in the life cycle. And the question there is we're asking is, what is touched? What information is touched by this one request for requirement change? So now looking at this, translating this into an actual document form. So here you don't need to, by the way, interrogate the actual writing of the document. This is only an example. In fact, the document on the left is an interface specification, a requirements interface specification. But notice that there are individual requirement statements, which I've highlighted with the red boxes. And at the moment, we're starting to work on the project, and you notice that some of those user interface requirements have been directly traced to system requirements on the right-hand side, the ones with the green boxes. Now, that's good news. I mean, first of all, we're starting to make progress, and we're starting to develop how we're going to move from the user requirement to the system requirement, how we actually start to move from the idea of what we need to achieve to how we're going to achieve that. But what's more important here is look at all of the requirements at this point which have not actually been traced to any information. You've got empty boxes, and those empty boxes are showing you the work that is still to be done. And this is where I'll talk about the development of what I term project metrics and completeness. And from this very crude analysis, I'm not going to say that it could be tracing to nonsense, but that's part of obviously the work we do as part of the project. But from this crude analysis, I can now assess that 35% of the requirements I've started with in terms of the user statements have been satisfied by some sort of system specification or system requirement, taking the next step of our design process on how we're going to satisfy and implement those user requirements. More importantly, though, it means that 65% of those requirements still have not been addressed in any way at all. And if I was the project manager, that is a key and critical piece of information for me. And as we develop these relationships, that traceability is giving us some view, some project metric on completeness of where we are at any given time. The other thing I talk about very often is this concept of linking the world of words with the world of pictures. And this is also important because if you're in an integrated project team or in a multidisciplined project that you're working on, some people, quite honestly, are better at working in the world of pictures, whereas other people actually feel much more comfortable working in the world of words. And I present this simple example because this is particularly meaningful to me, where if someone wants to explain on how to get from one location to another with a map, for me, give me the map any day. But other people like the preciseness and conciseness of having that same information presenting in words. And again, traceability says that if you're going to talk to both audiences and get the most out of both audiences, capitalizing on the individual strengths of everyone in your integrated project team, then you've got to have that traceability between the world of pictures and this could be the world of models, UML models, or moving and abstracting your requirements. And traceability plays an important role here as well. And we can also use traceability for the area concept of information reuse. For the stuff, and this is an example here of a car chassis. So you can have a project which is called the chassis. And by the way, that project is owned by the person responsible for that chassis. but then we want to now reuse that information in 3 different variants of that car. So the chassis is common, but we want to use that common chassis in the saloon car variant, in the sports car variant, and in the utility car variant. What's important here, we're using traceability here, the relationship called use by, to link those 3 variants back to the master. What is interesting though is that the projects themselves, the project 2, 3, and 4, can't actually change that chassis. They can actually, they can read the requirements and they can use the requirements. But if they need to actually make a change, they've got to go back to project 1 to seek authority to make that change, because project 1 has to take a view on, if I make that change to the chassis, what impact does it have on the other 2 vehicle variants. So this is another example where the use of traceability starts to allow you to truly reuse information. And what's interesting here, by the way, is that reuse is not only limited to the requirements themselves. If on the original specification you've traced that information to verification or test information, then there's nothing stopping you where you've reused that requirement, reusing the associated test and verification criteria. And that's another place where, particularly in starting up projects, you can actually save considerable time and effort in that process. The other area I've mentioned right at the end there was talking about traceability across tender documents. And this, by the way, sits on both sides of the camp, either the bidding side of the camp or the receipt of tenders. And this is where also you think about having this traceability to ensure that you've answered every single question that has been raised on you, every single requirement that your original customers asked for. Have I got explicit traceability to how I'm going to answer that question, that requirement in terms of my system implementation, and most importantly, what cost is associated with answering that question, and really importantly, have I truly answered every single element of the criteria that was originally placed upon me. And that has to be down again at sentence level, because you only have to miss out one sentence. You've missed one sentence or one requirement, and the potential impact or cost downstream where you have effectively contractually committed to saying, yes, I can answer, I can deliver what you've asked for, and then you discover at the very late point of your project life cycle the fact that that requirement has not been addressed, then you have to retrospectively engineer that requirement, or either be in breach of contract or renegotiate the contract. The clearest thing to do here is ensure that every single requirement from the original tender document is in some way addressed and linked to how you're going to answer that requirement in your delivered system. And again, it's really important, this traceability. You're not saying I'm compliant with the whole document. You are saying that I am compliant with every stated requirement that you have placed upon me in that document. And if I'm not fully compliant, then you need to reflect that in the response that you make to that bid. So now let's look at some of the business challenges associated with those issues. So how does one requirement change in one specification impact one or many requirement statements in the other associated documents? Well, on that, I've already gone through the fact that one change to one system requirement can actually have an impact on 5, 6, or 7 other documents if it's part of a project lifecycle. Or if I go back one step further, if my customer asks for one change to one of their original requirements, you need to very quickly assess in real time what is the impact going to be, what is touched by that change, and if I understand quickly what is touched by that change, you can much more quickly assess what is the cost associated with that change. So the business impact of not understanding the impact of that one change is it will result in retrospective rework, project delays, and the inevitable additional cost. And certainly from my brief encounter with the building industry, make no mistake, time is cost. If something takes longer, you're still employing the whole project team for that increased time, and make no mistake, it comes at a cost. So another business challenge: what is the cost to the project when the full impact of requirements change is not quickly identified? Well, I quite like the graphic here. You've got a railway line coming from two directions, and of course they don't meet in the middle. Again, the business impact is working on out-of-date information, result in expensive rework, project overrun, and again increased cost, but for a slightly different reason. So another business challenge is, how do we ensure that subcontracted system requirements or outsourced software requirements are fully satisfied? And again, this is establishing this one-to-one linking. And very often I would make the huge recommendation from my own background is that when you define a requirement that you're going to place onto a subcontractor or an outsourced business, at the same time, it's really brilliant if you can actually define not just the requirement, but how you want to verify that requirement, how you want to test against that requirement to ensure that what they deliver is what you're expecting. The benefit of that is, one, it validates whether the requirement you placed upon them is measurable. That's pretty useful. And number two, by giving them the information on how you expect to verify and test that they are compliant or that they've delivered against that requirement, you're giving yourself a second opportunity to fully explain what you mean by that requirement. It's a further opportunity to tease out that any ambiguity or any interpretation that could occur on that requirement by actually linking that requirement to its associated test and giving both those bits of information to your outsourced or subcontracted entity, gives them no room to interpret or misinterpret or reinterpret what you originally asked them. So again, the business impact here is system integration failure. Very often we don't discover that these requirements issues until the point at which we start to integrate the bits of system together, particularly on large complex systems. So system integration failure, which then results in rework, then delays, cost overruns, and in some instances, project penalties. So next one is, how do we explain explicit compliance to standards, legislation, and regulatory constraints? Now, very often I've seen this myself, where customers have glibly made reference to a standard or regulation, and as far as the customer is concerned, it's a single line. It's one line of text that says, you shall be compliant, or we need compliance with this particular regulatory standard or whatever. But for you can't just take that as a single line requirement. You've got to look at that standard, you've got to look at that regulation and say, what is actually relevant in that standard to this instance of this project? And not the whole standard is always going to be relevant. So you've got to draw out of that standard, out of that regulation, what requirements in those documents are actually relevant to this particular project, because not all of them will be. And you've got to draw out, they then become the requirements, and you seek agreement with your customer that says, you said you wanted compliance with this standard, well, on this instance of this project, only these parts of the standard are actually relevant. And that's really important. So business impact here is retrospective rework again, penalties for non-compliance to the nominated standard or non-agreement to what parts of that standard we need to comply with, because you don't, if you have to try and comply with the whole standard, some of that could be defined as gold plating or literally unnecessary cost. And finally, you may pick up penalties and fines for that non-compliance. So it is important, and again, establishing traceability, not at document level, but at individual statement level, becomes crucially important here. So requirements management must provide lifecycle traceability, and we talk about the lifecycle. We start at typically a customer requirement, or it could be a marketing idea, it could be a new product that your company wants to define, starting on the left-hand side, and if it doesn't actually address something that a potential customer is looking for, then you have to question why you're doing it in the first place. Your customer requirements, as we said, link to system requirements, which in turn link to subsystem requirements, and ultimately should link to some sort of test and verification. Traceability is key to that compliance. So initial requirements will be decomposed, which creates traceability relationships. This traceability must be enforced to ensure consistency and completeness with every requirement, and most importantly, with every requirement that may change during the life cycle of the project. And let's be real about this. Change happens. It has to happen. Sometimes it's through technological constraint, and sometimes it's through someone else comes up, or your customer comes up with a new bright idea of what they want to achieve with your delivered system or service. Traceability from customer requirements through to systems development, to test and delivery. This enables organizations to know which requirements are implemented and tested versus those which are not. Now, this is when I go back to my original statement about testing for completeness. How complete are we in our project? How far are we through everything that we've got to achieve? Manage and defend against scope creep. And this is a classic one where you end up with a load of system requirements which you cannot trace back to your customer requirements or your initial mission statement. And if you've got that, if you've got a system requirement or a subsystem requirement that you can't back trace to why you're developing it, you have to just ask the question, is this gold plating? Are we putting on some additional features which we've not either charged for, we're still paying for it? The only time when this may be acceptable is if you're reusing existing equipment and you want to reuse that equipment onto a new customer. But make sure if you've got additional system or subsystem requirements that are in your existing system, make sure that you gain some sort of commercial benefit out of them, even if it's only saying to your customer, if you come with us, if you select our product, by the way, you get these additional things and there's no additional charge for that. It's a benefit. But if you don't know about those extra features, then you're losing an opportunity to properly sell what you're delivering. So the other thing that you need to wrap around when you start to establish this concept of relationships between requirements across multiple documents is the importance of process, the importance of ensuring that everyone in your project team or everyone inside your product development team are aware of how all this information is connected together. You have to define a process. You have to define some sort of view of how you've actually linked the information together, so that when one person is working on one document, they know you can give them the context of where that document sits in the wider project. And that's where the concept of collaboration also comes into play. You cannot rely on Microsoft Word and Excel, which very often happens, to start sharing this information with your colleagues. Very often we want multiple people working on one document at one instance in time, but on different requirements in that document. So the concept of collaboration and having this requirements information in a central repository that everyone can access and everyone can see what everyone else is doing in real time. If we can actually achieve the first two, the concept of introducing process and the collaboration, product quality and delivering a complete system tends to go up, tends to improve. And going back to the process discussion, this is an example of how we need to establish a process backbone for representing all the requirement-related project artifacts. So notice here, it's not an incredibly clear picture, but hopefully you can see it. You've got user requirements, and we've actually got relationships, we've defined relationships, the traceability between other documents. So the user requirements are derived from customer requirements, marketing requirements, standards or regulations, or business rules. And those user requirements are then validated by acceptance tests at that level. The user requirements are then satisfied by system requirements, which are then verified by system tests, which in turn are satisfied by subsystem requirements, which are then validated or verified by subsystem tests. Notice on the left-hand side also you can link in risks, so you can actually have risks factored in, again with traceability to individual requirements, which are motivated by, and in actual fact they could be motivated by requirements in any of these particular documents. But in this case I've got it motivated by user requirements and system requirements. So at this point I'm going to hand over to Miguel, and he'll give a demonstration of how we can actually implement some of these capabilities. And also, again, if you start to think about questions, then raise your questions. I notice we've already got some questions coming through. Please raise the questions, and we will come back to those questions at the end of the presentation. So if you think about them, just write them down, and we will come back to you. So Miguel, if I can hand over to you, and you can present this capability and how you can actually achieve it in reality.
Okay, thanks a lot, Paul. That was really a very informative presentation. Good. So let me show you some examples on how a tool can help to perform effective impact analysis and test coverage when facing complex traceability challenges in a real environment. It will take me less than 10 minutes. Let's assume that I am the system engineer of a surgical imaging system. This is our block diagram. We are representing the V model of our architecture, similar to the picture that Paul showed before. In Visure Requirements, we can draw graphically the different type of artifacts or type of specifications. And obviously, the allowed relationships between them. So satisfied by. Well, as a system engineer, based on the system specification, let's assume that I am responsible for writing the subsystem requirements and tracing them to implement or to satisfy that system specification. If we take a look at both specifications, the system requirements and the subsystem requirements here, we will see that, well, let's say that I have already written some subsystem requirements. I have to say that, okay, based on this environmental specification, I will trace it to one particular requirement that we have defined. This is the environmental condition. So as you can see, I'm using the context menu, start and set the relationship, and I'm using the satisfy by motive as I defined it in the block diagram. Good. So we can see the relationship in the related items tab, and I can navigate as well. So, well, let's assume that I have finished writing the subsystem specification, and each system requirement is now linked to at least a subsystem requirement. Therefore, both specifications are ready to go. But after some time, due to some changes in the regulation or the standard, for instance, the product manager. Let me log it in. Product manager in the same project. So the product manager will modify some of these requirements to comply with that change in the standard. For instance, let's assume that I need to modify the environmental specification. I should change this from 5 to 10 degrees, and this one as well. Let me save it. So that's it. I already implemented the change. Then eventually the system engineer will have to log into the system again because he has been notified of a new version of the system specification, and then he needs to review if he has to modify the subsystem requirements according to these recent changes in the system specification. We simply refresh the screen here. We will see that the relationship between this environmental condition and the environmental specification from the system requirement is now suspect. Okay. So, well, I have to review it. In order to look for suspect relationships across all my subsystem requirements, I can open the traceability matrix between the system requirements and the subsystem requirements using the very block diagram here. So let me just activate the relationship. Now I'm seeing in rows, I'm displaying the system requirements, while in columns I'm displaying the subsystem requirements with the relationships in here. So I can see in red here, suspect indicator that is telling me that, well, the system requirement has been changed. So I need to check if the relationship is still valid. So I can see I can check which requirements have been changed in a heartbeat. There's no need to have canteen discussions or have lunch with the product manager to be notified of those changes. Good. So let's navigate to the system requirement that originated the suspect, because as a system engineer, I need to know the changes made to it. If I go to the versions tab, okay, I can see that it was the product manager, the one modifying it. I can see that he made it recently. And instead of reviewing the whole content, it will probably be easier to identify changes if I compare the latest version with the previous one using this nice track changes tool. Good. Now that I know what was actually changed, let me navigate this time to my target subsystem requirement. And, well, let's say that no changes are needed. Therefore, I can safely clear the suspect. That's it. Save it, and done. Excellent. But, well, let's assume that the system engineer wants to perform a deeper analysis because he thinks that the product manager may have not considered all relative artifacts touched by the change in the system specification. You can see changes in, I have to check if I'm still compliant with the user requirements. I may have to rewrite the test plan and execute it again, probably the subsystem tests as well. So let's analyze the full impact of the change by opening an upwards traceability view. I can check if the system requirement is still compliant with the customer requirement. Okay, and by opening a downwards traceability, I can check any impactive subsystem requirements or maybe test cases, etc. Let me show you another, a bit more complex example. The tool should be able to display the full traceability from the high-gas level, this is the customer requirement or customer request, to the system requirements, the subsystem requirements, or why not with the, even with the last result of the related test cases, when these meaningful colors here. It's very nice and very productive. Traceability reports are also key. Let me just display requirements covered by test report. This kind of reports are really useful to quickly identify the implementation progress of the project, or maybe the impact of a change or missing relationships. The traceability metrics are key to ensure project success. Okay, so just select the component requirements. This is maybe the subsystem requirements. What it is displaying is the subsystem requirements or component requirements along with the relative test cases here. And I can quickly identify that I have some requirements here not being covered by a test case. And well, it is really useful to count on some metrics like this one, where I can see the percentage of requirements being covered by test case and how many do I have not being covered by test cases, just as an example. Okay, so that's basically it. I hope you have got a clear picture on some useful features that the requirements tool should have to allow us to have full control over all related artifacts and the changes made to them. So I will now hand over to Paul again. Thanks a lot.
Lovely. Thank you, Miguel. We will come back to that demonstration, by the way, because one of the questions that's come through, which we'll cover at the end, will need us to show some other block diagrams of the traceability down into the software and the code. So if you can prepare yourself for that, Miguel, we'll come back to that in a minute. So so just a very brief repeat of the diagram that you saw earlier on. So in Miguel's presentation, this was a typical V diagram of, in this case, a system engineering process. We will talk about how we can actually establish traceability further down into the life cycle, down into the software development, the software modules, etc. But we were just, for the purposes of this discussion, maintaining traceability at this level. Obviously, there's no actual constraints as to how far you take that traceability. But it is interesting in the presentation. It does open up those questions about, what is if you change that system requirement, what is the impact on system test? Are we still compliant with the customer requirement? What is the impact with the subsystem requirement? And of course, you need to track that change across to the test information. It's back to that canteen discussion that said, oh, did you realize we changed the box from red to green? And as far as the tester was concerned, he was still testing for a red box. So when the green box came through, in simple terms, the test is going to fail. And it is about communication of that type of information. So going on to the next slide, if I can make it work. Oh, okay, here you go. So Visure supports it. So the traceability lifecycle starts at the original statement of need, wherever that comes from, whether it's marketing, whether it's your customers, whether wherever you get initial seed of what is required, is how we trace that through the lifecycle to at the end delivering that solution. And that solution could be a product or it could be a service, but it's maintaining that truth of traceability through the various steps that inevitably very often occur through that life cycle. But in establishing traceability, there's two things I want to highlight here. First of all, there are no silver bullets or shortcuts to establishing and maintaining information traceability. It takes effort, and it takes effort to actually do this, and it takes a commitment on everyone in the project to establish this traceability as an integral part of the project activity or the system development activity. But once you've made that investment, the fact that you can actually in real time understand what is touched by a change, what is touched by one piece of information changing, and because you can do that in real time, you can very quickly assess the impact, both in terms of cost and time, on the project. That investment, in my view, is worth making. It is even more difficult to manage manually, and this is my manual knife and forking, the little character there. So if you've got these islands of information, and one thing changes in one of the islands, the reality is, at the point of that change being made, the only person who knows about that change is the person making the change in that island, in that Word document, or in that Excel document, or in that Visio picture. The reality is we have to establish traceability to bring and wire that information together if we're going to get the benefit of understanding the impact of future change. So the cost of, you can do it manually, absolutely. And on smaller projects, people do it manually. That's always where we start. As the projects get bigger, as the projects involve more people, then you really need to think about this concept of maintaining traceability across multiple documents. So very quickly, the business benefits of maintaining traceability: it allows projects and development managers to monitor status and completeness, ensures clarity of understanding between all the parties within your business and all the contractual parties. It means that at any point you can say that 35 or 40 or 50% of my user or my customer requirements in some way linked to some sort of test, either a test specification or a system requirement. It allows you the ability to demonstrate compliance with customer requirements, or it could be a tender response. Makes it easier to secure payment on given contractual milestones, or it makes it easier in the tendering situation to secure that project and be confident that every requirement that your customers ask for is in some way addressed in the response that you've made. It provides accurate allocation of requirements to subcontractors, so that every single requirement that you place on a subcontractor, ideally with its test, they've got a very clear understanding of what they've got to deliver back. And when they do deliver it back, you can then actually monitor at the statement level how you're going to measure their compliance and how you're going to measure that they've actually achieved what you've originally asked them for. And then finally, the analysis of the impact of change increases the commercial opportunities and decreases the risk associated with change. So if the customer asks for a change, you can go back, and of course we always want to, the customer's always right. I mean, you always want to go back and say, yes, we can deliver what you've asked for, but if you've actually traced this information through, you can very quickly say, yes, we can do that, but the impact on the project is going to be this, it's going to take this amount longer, and the cost associated with it is going to cost this, rather than just say, yes, I can do it, and make no charge. And what you're actually doing is taking money straight off your bottom line. And finally, avoids the need for unnecessary and retrospective rework and eventually product recalls, as you've often heard about in the automotive industry. So with that, we do have some questions that are coming, and I'm going to ask Miguel to participate in helping me answer these questions, and we'll go back and see what we can do.